Hi everyone, welcome to today's webinar. My name is Bilal Amjad, and I have with me here my colleague.
Hello, hi all. My name is Nadim Ishker, and I'm a global AI cloud solution architect in Microsoft. And it's a pleasure to present this webinar for you today.
Thank you, Nadeem, for the intro. So today we'll be talking about Azure AI Landing Zones for production at scale. And the agenda that we will be walking you through is giving you a quick intro about Foundry, the well-architected framework and the AI workload, the cloud adoption framework, and the AI scenario in it. Then we'll talk about Azure Landing Zones, and then the most important bit where we talk about the AI Landing Zones. And then for the demo, I will be handing it over to my colleague, Nadeem, who will be giving us an extensive demo of how you can actually scale and accelerate your AI use cases to production with AI landing zones. So before I kind of kick off, I would like to start off with the problem or the challenge that our customers are facing in their AI use cases going to production. And this slide has various details based on various research that you see here. But the key thing probably that sticks out for me is that for companies that have figured out how to get their AI use cases to production, it takes them around 12 weeks to do that. And within 12 weeks, they start realizing return on investment on their efforts and the investments that they've made into AI for a particular use case. For companies that haven't figured out how to go to production with AI, they're taking up to 12 months. And 12 months is a long time, especially in the age of AI, for any company to take their AI use cases. The thing that we are seeing here is that companies are struggling at a particular point in their journey to go beyond that point and take their AI use cases into production. And this graph here represents that particular point. So we start off with an intent of an AI use case. We do a POC. The POC is successful, and we see the benefits of AI. But then as we going into production with that AI use case, that's where the blocker and the challenges start coming in. And that's what we're going to be addressing today in today's webinar as to helping you get beyond that point and helping you become one of those organizations which can get their AI use cases in production into 12 weeks rather than 12 months. So let's talk about a few things with which Microsoft helps you, starting off with Microsoft Foundry. Microsoft Foundry is part of our AI platform, and our AI platform is spread across IaaS, PaaS, and SaaS. So in infrastructure as a service, you can use our GPU and containers to set up an AI platform yourself. A platform as a service point, you can accelerate that platform setup for AI using Microsoft Foundry with the agent service. And then for a software as a service, which is a low code or no code scenario, you can use Copilot Studio. The key thing that we hear about is agents, how agents across these different AI platforms can be built to help businesses accelerate their value. Now, agents are essentially composed of an LLM model, an instruction set, and the tools that you plug into it. The agents take inputs. Those inputs can be from system messages, user messages, or other agents themselves. You plug in your tools, which allow the agent to do retrieval, certain actions, and have memory. And then the agent is able to give us an output with its own messages and tool results. So Microsoft Foundry is our premier AI platform service, which basically gives you the ability to accelerate your agent development. And you can use our models, our agent service, our IQ tools, and machine learning coupled with control plane. This gives you a complete platform which is also has security, compliance, and governance built into it with Agent 365, Defender Purview, and Intra integrated into it. Now, you might have seen an architecture like this at various conferences or other presentations as well, which shows you how a reference architecture of setting up Foundry should look like. You can see some of the bring your own resources that you can connect into Foundry, the AI APIM that acts as your AI gateway, the Foundry agent service, coupled with the Foundry control plane, and then the Foundry agent framework as well. But the key thing here is that this architecture does not scale into production. It's not an architecture which an architect will sign off on. And that's what AI Landing Zone is basically for helping solve for you. So we'll be discussing that a bit later, and we will be showing you a revised version of this architecture later in the webinar. Alongside our product, you will find two frameworks. One is called the well-architected framework, and the other is called the cloud adoption framework. So let's talk about the well-architected framework and the AI workload first. So the well-architected framework is basically our framework for guiding you on how to address reliability, security, cost optimization, operational excellence, and performance efficiencies in your workload design. The AI workload is basically a reference workload that we provide you in terms of how you should structure your AI workloads for AI use cases. Along with that, the cloud adoption framework and the AI scenario is basically our adoption framework on how you can adopt an AI in your enterprise at a platform level, not just at a particular workload level, but across the whole platform. It helps you define the strategy, put a plan in place. According to that plan, you prepare your environments and ready your environments, and then you start your adoption. While you're doing that, you basically govern, manage, and secure throughout this process. AI adoption scenario within Cloud Adoption Framework essentially gives you the mechanism of applying those stages and those phases to your AI adoption at your enterprise. And as I mentioned, for the whole of your organization, not just for one particular workload. So you can basically use the cloud adoption framework methodologies for strategy, plan, ready, govern, manage, and secure, but focused particularly on AI. So now that we talked about our product, which is Microsoft Foundry, our architecture frameworks, which are the well-architected framework and the cloud adoption framework, let's talk about landing zones. And we'll start with Azure landing zones first, and then we'll head towards AI landing zones. And landing zones is a concept which is basically part of the cloud adoption framework. And you should think of landing zones like a city. And as if you're the architect of that city and you're setting up the city for various types of buildings to be built in it. Just like if you're an IT architect, you would set up a platform for various kinds of workloads and applications to be hosted on that platform in your organization. So just like in a city, before somebody constructs something, whether that's a house or a bridge or a stadium, you would provide them with some utility services that are shared, and that would include water, electricity, sewage, and other things. So just applying that to our IT use case, you would supply networking, identity, policies, and operations management and monitoring for them to be able to plug into it and leverage it. So going back to that example of what different kind of buildings you would build in a city, a house, a stadium, a bridge, all of them would basically have different requirements and different foundations that would be needed. So similar to this example, an SAP or an Oracle workload or an AI workload would differ and would have different foundations that would need to be built. So that example continues here, and you would see that as you build your AI workload and your SAP workload or your Oracle workload, they would have the need for building different foundations, but within the same platform. What are landing zones essentially for? What they do is that they give you a starting to a journey based on best practices, creating a well-designed foundation for you, helping you use a consistent, repeatable environment design, and baking in the best practices for you. They enable migration and net new app development in your platform. They consider all platform resources, and there's no differentiation between IaaS and PaaS resources. So when you set up an environment using landing zones or Azure landing zones, they help you scale, secure, govern, set up networking and identity so that the platform is set up on top of which your applications and workloads can come in. There are certain design principles that landing zones follow, starting with subscription democratization, policy-driven governance, single control and management plane, application-centric and archetype-neutral environment setup, and then last but not the least, Azure native design and platform roadmap alignment. And along with our design principles, we have design areas that landing zones follow. So in our design areas are broken up into two parts, environment and compliance. So in environment, we look at setting up Azure billing and Azure Active Directory tenant, identity and access management, resource organization, network topology and connectivity, security, governance, management, platform automation, and DevOps make up the compliance and design areas. So we talked about the platform level landing zones, which are Azure landing zones. Then alongside platform level landing zones, there are workload specific landing zones as well. And what those workload specific landing zones help you do is that as you set up your platform with Azure landing zones, on top of it comes your AI landing zone, and then on top of it comes your AI use case. So you can really see that the majority or the bulk of the implementation of getting an AI use case to production depends on how you set up your platform for the platform landing zone, how you set up your AI landing zone, and then on top of it comes your AI use case. So the Azure Landing Zone conceptual architecture basically represents the target state for most organization. It gives you a scaled out and mature environment from the start. We have customer and partner best practices baked into this design, and this gives you a strong foundation for management, governance, and security in your environment. And then within this architecture, as you can see highlighted here, the app or workload landing zone is depicted here. The rest is basically the platform that you set up. This landing zone for your app or workload is equivalent to as many workloads or applications you would have. So you would set up a landing zone for your app or workload as you bring in more workloads and applications onto the Azure platform. And the full journey looks something like this. You start with bootstrapping your environment by creating the platform subscriptions. Once you've done that, you deploy Azure Landing Zone platform components using one of our accelerators, whether that's the Portal, Bicep, or Terraform accelerator. And then following that, you set up a subscription vending process or a landing zone vending process so that whenever an application or a workload team comes to ask you to deploy an application, you can basically vend them the landing zone and create that landing zone for them using our landing zone modules for Bicep and Terraform. And then last but not the least, the landing zone accelerators help you deploy a particular type of workload. It could be AKS, SAP, Oracle, AVD, or in today's case, which we will be discussing, an AI landing zone. So let's talk about AI landing zones now. AI landing zones essentially put together everything that you've seen up till now. We talked about the product, which is Microsoft Foundry. We talked about the well-architected framework, the cloud adoption framework, and we talked about Azure landing zones. So that's a lot for a customer to process through and get the best practices across all these four to set up an AI use case in production. So AI landing zones help you accelerate that by bringing all of those together and giving you a design framework with reference architecture and extensible implementation for Microsoft Foundry. As I was mentioning, the key components of AI Landing Zone are the design framework, which are based on the Cloud Adoption Framework, the well-architected framework, our guidance from Azure Architecture Center as well, and our product guidance. We have reference architectures for a Foundry landing zone and an AI Gateway landing zone. And the AI landing zone basically supports and works in conjunction with the platform landing zones that you set up using Azure landing zones. Also, last but not the least, if you don't have implementations available for it, you won't be able to actually implement this in your environment. So we provide you with extensible implementations in the form of Terraform, Bicep, and Portal. Focusing on the design framework, the design framework is a framework of design areas which are based on AI design areas, the cloud adoption framework, and the well-architected framework. And they bring together guidance across each of these design areas, what you need to think about or what you need to consider as a design choice while you're designing your AI landing zone, and what is our recommendation. And then you basically, based on that, you make your decision on how you will go ahead with setting up your AI landing zone. These design areas give you full coverage across whatever you might need to design for your AI landing zone. Just like a city architect or a building architect would need to make sure that they're designing for everything at the start rather than missing something and then having to deal with that later. And this is coupled with our reference architecture, which is basically our blueprint. And the reference architectures are available in two formats. We have an AI Gateway landing zone and an AI Foundry landing zone available. Both of these reference architectures are meant for production and helping you go to production. So the reference architecture that I showed you a while before in our webinar, those reference architectures now translate into more detailed, low-level design architectures, which you can leverage and plan and adopt as you go to production. And then last but not the least, extensible implementations. So based on where you are in your journey in terms of doing deployments on Azure, whether that's through Portal or through Terraform or through Bicep, we have options available for you to cover all the scenarios from infrastructure as a code options to standard Portal options as well that you can leverage to deploy. Coming towards the end of my part of the presentation before I hand over to my colleague Nadeem, imagine if this triangle at the top represents your AI application. What does it take to get this AI application into production? So the first thing that you would do is to set up your platform infrastructure if you haven't set that up already using Azure Landing Zones. Once you have that, on top of it, you set up your application infrastructure with AI Landing Zones. And then on top of it, you do your development for your application use case, whether that's a RAG or a document processing or fine tuning, and deploy that. Then your AI application goes into production. So there's a lot of things that need to happen before an AI application gets into production. And both Azure Landing Zones and AI Landing Zones help you accelerate quite a big portion of that. With that, I'm going to hand over for the demo of AI Landing Zones to Nadeem, and he'll be giving you a walkthrough of everything that I presented to you and diving into more details around how you can use AI Landing Zones. Nadeem, over to you.
Okay, thanks, Bilal. So let me first start with presenting mainly the AI landing zones, navigating to the AI landing zone documentation. Here we can see both the aka.ms/AILZ mainly takes you to the AI landing zones documentation. Here we have a full detailed documentation of the reference architectures, both the AI landing zone for Aping, mainly the AI Hub Gateway, as well as the AI landing zone for Foundry. And these two, as well as Bilal mentioned, kind of layer the foundation for building your AI infrastructure on top of the Azure Landing Zone. So the AI Landing Zone for Foundry, with its reference architecture, can be deployed. There are Bicep, Terraform, and you can also use ClickOps as part of the portal. But I'm going to focus on the AI Hub Gateway Landing Zone as part of this demo here. And before that, let me just maybe first ask a question. Why do we need a governance hub in the first place? And why do we need mainly a landing zone that functions as an AI hub for my AI endpoints? So every enterprise is racing to put generative AI into production, and almost all of them hit the same wall. We have individual teams who spin up their own Foundry resources, generate their own keys, and then they start working on their use case. Within a couple of weeks, you have more of a model sprawl, and no one can really answer the question of how much are we spending on AI and by which team. There are no shared guardrails. Sensitive data might be flowing to models unredacted, and a single misbehaving agent in a use case can exhaust your whole AI quota of your models, and it might take down everyone else as well. Security has no choke point, finance has no attribution, and platform teams have really no control. So that's mainly why we have the AI Hub Gateway, and it tries to answer that governance problem. In the reference architecture, we can see we have, as part of the deployment itself, we deploy the full infrastructure. We deploy an optional Foundry account and a Foundry project that you could use as part of the deployment if you want to test it out or validate your configurations. The whole AI Hub landing zone and the reference accelerator for that also deploys the full networking part of it. There are options if you want to deploy in a greenfield setting, so we can start with a VNet and all the private endpoints come into play, or if you want to provision in a brownfield setting where you already have the Azure landing zone, you have your whole networking setup working, and you can hook into that as well. At the core of the AI Hub landing zone, of course, as you might guess, is the API management gateway that really functions as the front door into all of your AI models, be it a Foundry deployment or a AWS Bedrock, for example, or any other third-party provider. So you can build that full governance layer that is secure and that is monitored as well. So you kind of secure and manage the whole cycle. So the AI Hub gateway itself, of course, can be deployed in addition to the AI landing zone for Foundry. So you deploy the AI landing zone for Foundry to start with, where you have your Foundry account, all the models deployed and managed there, and then you deploy the AI Hub landing zone on top of that. And in this demo today, we're gonna look at the AI Hub gateway landing zone using Terraform. So we're going to run a full deployment of the Terraform version of the AI Hub landing zone, which mainly deploys for us the virtual network, the API management gateway, private endpoints, and the extra additional resources that are used for metering, Cosmos database, logic apps, and event hubs for capturing streams and the monitoring part. We start off by cloning the repo. There are a number of prerequisites as well. We start off by cloning the repo. We can bootstrap the state as well. And then it's really a matter of creating our variables file. And we will be using one of the example variables files that we have as part of the repo. Let me move over to VS Code here, as you can see, where I have the cloned repo of the AI Hub gateway landing zone for Terraform. And you can see here the full structure of it. We have multiple modules, and we'll get into the details of those. And in the scripts folder, there are additional deployment scripts that we have prepared for you that help in the execution of the landing zone. So you don't need to worry about running Terraform commands. You just run a single script, run all the Terraform commands for you, and provision the whole landing zone. Starting off with deployment script, and before that, we create our environments. So there are two environment examples here, one for a dev deployment and another one for a prod deployment. Those have different configuration values, different sizing for the different resources. And in this demo, so I have prepared a dev variables file in my dev tf-vars file here. One thing you can see as well here that as part of the configuration, so the configuration properties are grouped into different sections, each managing mainly one part of the deployment. We have the basic configuration where we define the environment name, the resource group name, and then below there we have additional properties that look at security, networking, if you want to look into an existing network. So kicking off the deployment using my dev tf-vars environment file, I execute the deploy script with the dev parameter and with the auto-approved flag, so it doesn't prompt me for approvals. That's built into the script. And that's mainly the first step of setting up the platform. This is the foundation that everything else really attaches to. And this helper deployment script provisions the entire hub in one go. It first performs some validation checks, as we can see, and then it runs Terraform init, Terraform plan, and Terraform apply to apply the whole Terraform templates. Running this deployment script stands up the entire control plane for us, and that's mainly the first step of it. And this is mainly the long pole of the whole deployment. The deployment itself takes around 25 to 30 minutes. Obviously, I have sped that up here. And once it's done, the script outputs the key variables that will be needed mainly for the rest of the demo. And you can see also as a next step, I can run a validate script to validate the actual deployment. It's part of the scripts available, and it does some checks as well. Okay, so now we have the deployment up and running, the core infrastructure components of the AI Hub. Switching over to the portal and looking into my resource group here, everything that has been deployed mainly lands into this resource group, which makes the lifecycle management and cost tracking straightforward as well. We have one group, one deployment, and one platform owner. So we can manage the full AI Hub gateway deployment here. We can see here the Foundry account that I have deployed, the optional one. So we can hook into an existing Foundry account as well, and we'll see that when we start the onboarding activities. We have the API Center and the API Management Service, which is really at the center of this. So let me open the API Management Service. Here we can see in the portal the API management. I have chosen here the developer SKU. That's part of the variables file that I have defined. And looking at the backends in my API gateway here, I can see two backends that have been deployed. These have been configured in the variables file. These are more of a samples that can be used as part of the development or testing and validating that my full configuration is valid. If I go over to the APIs blade as well, you'll see that the gateway isn't empty. We have the Universal API, the Unified API, and the Azure OpenAI compatible API. They are all already published. That's the auto routing I mentioned as part of the deployment. So if these backends are configured in my environment variables file, then those will also be deployed as part of the initial core platform deployment. If we look at the Universal LLM API itself, so we can see here there are a number of endpoints and operations on it that really fulfill more or less all the use case needed for my use case and for my application to be able to consume the LLM through this governed and monitored and authenticated gateway. All right, so now we have the hub is live. We have the private API gateway. Foundry is sitting behind it, and the full usage metering pipeline is wired end to end. Every call now that flows through this gateway is authenticated, governed, and metered. But in the real world, so we have the platform, and we need to do model onboarding as well, and that's never really a one-time event. So models are always added. There is a continuous stream of models that ship almost every week, if not every day. And you want to add as well a second region for failover. You want to bring maybe an external resource from an external provider like AWS Bedrock or Gemini endpoints. And if you would need to redeploy the whole platform every time there is a new model or a new model to be onboarded, then that's really a time-consuming and an error-prone activity. That's why we have split the deployment into different modules. So the LLM backend onboarding is its own module, and there is an extensive documentation for that as well. We can see in the README file. It details what gets created and any prerequisites, and this hooks into an existing APIM gateway deployment, and it then builds on top of that. There are, of course, the Terraform variable example file, which is as well part of the Accelerator. There are a number of configs to be added here so that you can then onboard your backends. There are a number of backend types that we support. So we have AI Foundry. If you have an Azure OpenAI service as well, AWS Bedrock, Google Gemini, and any external endpoint as well, if you want to include that and govern that as well through the same APIM gateway. Defining the LLM backend config is really simple. It's a list of JSON objects, basically, where I define my backend type, the endpoints, the authentication scheme, and then the supported models that are provided by this endpoint. So this is an example that you find as part of the Accelerator in the GitHub repo. Of course, you can add your own endpoints and your own models. And this also enables you to add multiple backends. So if you want to have more of a failover scenario with a primary and a secondary deployment, this shows an example of a secondary Foundry backend type with another endpoint, maybe routing to a different region altogether in terms of if my primary region fails. And I can also add additional backends. So here is an example for an Azure OpenAI and AWS Bedrock, and as well an example for a backend of Google Gemini. Similar to the backends, I can define as well model aliases. This mainly creates a name for my models, and I can create a list of models behind that name, and that name would be then used, or that alias would be used by the applications. They don't need to know which model is being called. I can configure that based on a strategy, and there are different strategies that can be used, and that enables as well switching models. So if a model retires, you can easily switch that without really impacting the application consuming that. So as I mentioned, this is its own module. There are scripts to provision that, but we have also prepared a number of Jupyter notebooks for you to really be able to see and visualize the whole steps. The execution happens in multiple cells, so you can see exactly all the steps that are needed to onboard your backends. And once you are happy with that, you can take the configuration and apply that to your own deployment pipelines. So whenever there is a new pull request approved, it can then automatically deploy to your Azure environment. So here you can see I will be running this notebook. First, I'm defining the configuration values, defining my resource group name and the location. And then the notebook really goes and connects to that resource group and fetches the deployment from there and applies the backend config that I have configured here. So here I have mainly my primary AI Foundry endpoint or my backend with two models that are being supported here. So I have a GPT-5.4 mini and a GPT-5.4. These are pre-deployed in my Foundry account. And I have as well another secondary Foundry account as well with the endpoint with the same set of models. So I have a primary and a secondary deployment where I have priorities different. And then the APIM decides based on the priority which mainly backend to route the request to. I'm also defining some model aliases here to show and demonstrate that functionality also. You can have a single model name as well, a single model for an alias or multiple. If you have multiple, then you can specify like a weighted strategy and give weights. So the requests mainly are routed to the model based on the weights and so on. So let me run through this whole notebook and let's see what happens mainly. So first it kind of initializes the configuration, the connection to the APIM. And I can see then that in my existing APIM, I have a number of backends that are already onboarded. I see set backend pools. And then the next step, it kind of reads through my configuration and tells me that, okay, this is what I already have, and shows me the configuration, the identity, and then it generates mainly the Terraform variables file. So the notebook itself generates the Terraform variables file based on the configuration I have defined above. And it shows me what's going to be deployed. Once that is okay, then it goes and generates the file. So here are the full configuration. This cell mainly generates the Terraform variables file itself. And that file I can then take, if I'm happy with the configuration, with the deployment, check that in my deployment pipeline and use that for my LLM and automated deployments. If we look at this file itself, if we see on the left side here, that is the file generated. You can see that it has my full configuration, the backend config with all the properties, the models I have defined, as well as the aliases. And then the notebook as the next step, what it does, if I go over to that again, it actually uses the Terraform commands. So the notebook itself runs the same Terraform commands in it, plan and apply, that the scripts in the module would run as well. So it's the full execution. So the notebook mainly helps in validating that. Once the deployment is done, I can see that now, yes, my backend is deployed. I have two models that I have defined and the endpoints with my backends and the pools that have been created. And then I can start also testing out those deployments as part of this. Here it's running mainly through the API. So it's actually calling to the API management gateway, testing out the model deployments. So making sure my backends have been properly deployed, and also kind of validating with different configurations for both of the models that I have deployed. Okay, so this now we have the models deployed, and we can see that it kind of executed. I can test as well that, look at that. If I navigate over to the portal, I can look at the backends. I can see my two backends here have been provisioned as backends, and as well the policies, mainly in APIM, have been all updated as well to those two backends that I have defined. But having now the models are flowing through the gateway, but there is still a governance gap here. So anyone holding really a master subscription key can still call any model. That's fine maybe for smoke testing, development, but that's really the opposite of what most enterprises needs. There is no per team attribution, no scope limits, no way to revoke one team's access without affecting everyone. And that's where kind of it takes us to the next step or part of the deployment. And that's mainly if I go over on the left side, my new module, the Citadel Access Contracts. And that's where really Access Contracts completes the picture. So we have deployed the platform, deployed the backends, and now we can deploy Access Contracts. And what it really does, it creates products in APIM for every team or use case with its own subscription key, with its own policy. And this module as well has an extensive README file, so you can look at that with all the details of what gets deployed, how it does that, and the prerequisites for it as well. Yeah, you can see here what gets deployed. So it runs through the steps, it creates the products, it creates the subscription keys. If I want to create to store those keys in a key vault, I can configure that. Or if I want to just use direct credentials. If I want to enable a Foundry connection as well for my product, also I can configure that. So there are the scripts similar to the backend onboarding module, helper scripts, but also here we have a notebook, and that also helps us visualize all the steps. And let me run through that as well. So we have the variables similar to the previous one. I defined the resource group name and the location, and then the rest of the cells mainly connect to that, initializes the API and client tools, and that's where mainly the main part of here. So for this demo, let's make it concrete. So I have a sales team that they want to build a customer support assistant, and they want to be onboarded here. So let us onboard that. We can define the access contract configuration for that. Here, mainly as well, it's a simple JSON list with objects, each object defining a single access contract. So a use case, I give it a name, I give it a business unit, and I define as well the allowed models for this access contract. So here we start that governance part. So here I can control which mainly use case is allowed to which models, and the capacity allocations as well. So the limits for that, token quota, and the different access contracts. So here I have a few that I will be showing running through for, say, 3 different use cases, running through that. And then here as well, one thing to note, so for 2 of the use cases, I have allowed GPT-5.4 mini, but not for the first one. So running through the cells really goes through that. And the similar approach here, we generate the Terraform variables file. These files, if you look on the left side, they come under the contracts folder, that folder over there. And we can see the variables files. These are the generated ones. Again, if I'm happy with that part of my deployment, I can take those, check those in my repo, and then include those as part of the deployment pipelines. So here we run the actual deployment. Similarly, here we run the Terraform commands init, plan, and apply. And it deploys our contracts. And what this mainly creates, it creates the products and the subscriptions in the API management gateway with the associated policies. And then we go on and test out those new access contracts. So here I'm testing using a GPT 5.4 model. And as expected, my first contract is denied access to that because I haven't really allowed it access to that GPT 5.4 mini. So this shows you like you can control which use case mainly can access which model and how you can manage that. The other two use cases mainly returned OK results as these were allowed, and that's the policies mainly kicking in APIM and managing that. Then I can do some stress testing. I'm using the same model here for my first use case. For my first contract, mainly it was failing. That's because I didn't give it access to that model. But the two others were successful, and I can also view in charts some diagrams here, the performance and the token count used, and any degradation here in response times. So this gives me like a full view and full kind of picture into my deployment. If it was all okay, then we can take it to the next step. Okay, so now we have the deployment, and I can show you here, if I go back to the portal and show you, here are the products being deployed. These are the 3 products. And if I go over to the subscriptions part, I have the subscriptions, and I can then share those keys with the respective teams. And I have a fully kind of managed APIM as a front door to my AI platform. All the models are governed, they are secured, they are metered, and I have as well capacity limits per use case. Okay, so this mainly concludes our demo here. Maybe let's take a step back and just look at what we have done here. We have deployed the platform. We have onboarded a number of LLM endpoints, and we have enabled access contracts. It's really those 3 operations that I want you to take away from this demo: setting up the hub, onboarding new model backends as a separate activity, and then finally access contracts that govern access and usage. And each one of those is its own module. So that's kind of enables the full management and the full life cycle of that.
Thank you so much, Nadeem, for that amazing demo. I think in the demo, you've shown us how we can use AI landing zones to go to production at scale. And now I think the next step here that I wanted to share with everyone is explore AI landing zones. You can use this QR code or this short link of aka.ms/AILC. This should get you to our documentation website, which provides you details on our reference design, our architecture, and our implementation options. And then you can start using AI landing zones in your organizations. And with that, I would like to, on behalf of me and Nadeem, I would like to just thank you all for your attendance today, and hoping to see you in a future webinar. Thank you. Have a great day.
Thank you.